In this problem, we are going to do a moles to grams conversion, in which we're asked to calculate the number of moles of lead in a 10.0 gram sample. The conversion factor that we'll need can be obtained from the periodic table, and the relationship is that 1 mole of lead is equivalent to 207.2 grams of lead. Notice that 207.2 is the atomic mass of lead, but when we give it units of grams, we can set it equal to 1 mole. It's called the molar mass. The solution to this problem amounts to taking the given quantity, 10 grams of lead, and using that conversion factor such that grams of lead cancel out, leaving us just with moles of lead as an answer. And the answer that we get should have 3 significant figures, and we get 0.0483 moles of lead. The second problem is a mass to atoms conversion problem, in which we're asked to calculate the mass in grams of copper needed to have 4.59 times 10 to the 25th power atoms of copper. In this problem, we're going to need 2 conversion factors. The first is the relationship between moles and particles. In this case, we're dealing with an element in its atomic form, so the particles are atoms. So 1 mole of copper is equivalent to 6.022 times 10 to the 23rd power atoms. And the second conversion factor we'll need is the molar mass. 1 mole of copper is equivalent to its atomic mass of 63.55, in this case expressed in grams of copper. The solution involves taking the given quantity in atoms of copper, using Avogadro's number as a relationship to convert from atoms of copper to moles of copper. Then once we have moles of copper, we'll use the molar mass in a second step to convert from moles to grams of copper. Notice that all of the units have canceled out here except the desired units of grams of copper. And the answer that we get with 3 significant figures is 4,840 grams of copper.